Hi, welcome to all of you. In my last video, I have explained what is the actual meaning of dy by dx. dy by dx is nothing but slope of a tangent line. So having understood that particular concept, let's come to these points. And these particular points, or you can say the concept, is really important, or you can say the prerequisite to understand the partial derivative and gradient descent algorithm. Why I am saying that? The gradient descent algorithm will use partial derivative, and the partial derivative will use all these concepts. So if someone new to this particular concept, for them it is really required, or we can say it is really must to have a knowledge about this particular topics. So let's go one by one. I am going to discuss domain, range, trigonometric functions, some important formula to do differentiation, then product rule, quotient rule, and chain rule to do the differentiation. So let us go and understand what is domain. So let's understand first what is domain. What is domain of a particular function? So when someone says that, tell me what is the domain of, let's suppose, this particular function y equal to x square. So what is the literal meaning of domain? If someone asks what is the meaning, what you are saying domain. So domain is nothing but all possible input value that function can take. Input value this particular function can take. So all possible input values that function can take. So input values is nothing but x, independent variable. Here x is the independent variable, y is dependent variable, depend on x, and x is independent. So the input will go to x and y will produce output. So x will take as domain and y will produce take all value in this particular range. So let's understand what is the range of this y equal to x square. So to understand, let's have a graph of this. Graph is nothing but this is y equal to x square. So this graph clearly explain you what is the all value of x and what is the all value of y this particular function will take. So let's examine what all values this particular function will take. So by looking that, you can see that it is taking all values from minus infinity to plus infinity. But do you think for all values from minus infinity to plus infinity, it is producing both side of y as output? No, because it is only giving on positive side of y. So what is the domain here for this particular function? So when you say the domain x belongs to minus infinity to plus infinity, so x will take all values from minus infinity to plus infinity. Same time, what is the range of this particular function? So y will be always greater than equal to 0. You, no matter what value you put for x, it will always produce you greater than and equal to 0. Similarly, can you please tell me what is the domain and range of this particular function? This is nothing but, you can remember, y equal to minus x square. Tell me quickly what is the domain and range of this particular function. Similarly here, so the only difference here, it is also taking from minus infinity to plus infinity. This is x and this is y-axis, positive side of y, this is negative side of y, this is negative side of x, this is positive side of x. So if you see here, domain of this particular function x belonging to minus infinity to plus infinity. But what is the range of this particular function? So range here, if you see, y will be less than equal to 0 always, no matter what value you put for x. Range, the output will be always less than and equal to 0. You can see here at the y side. So I hope you would have understood what is the meaning of domain and range and how to calculate it. Let's take one couple of example to understand more. So can you tell me what is the range of this particular function? If you would have understood what is the domain and range of a function and how to calculate this, so you can tell for this one. So take some time and then think about that. Okay, so let me explain what is the range and domain of this particular function. So as you know that inside this root, everything, all values should be greater than equal to 0. That means what is non-negative to be defined this function. So can we say that 4 minus x square minus y square should be greater than and equal to 0? For this particular value only this function will be defined, because inside this root it should always be greater than equal to 0. So that means whatever is inside this root, that will value will take greater than equal to 0, then only it will be defined, right? So if it is written like that, 4 minus x square minus y square greater than 0, so can we write by solving this x square plus y square less than equal to 4? So if you write this function like this, x square plus y square, what I have done it, I have just taken the minus as a common. So now if you see this, so as we know that inside root, this should be greater than equal to 0. So for what value of x square plus y square this will be greater than 0? So this should be always less than equal to 4. So if you give 5 here, let's see what happens. 4 minus 5, it will come minus 1. So this is not defined. So you would have understood x square plus y square should be always less than equal to 4, then only this will be defined. So what is the domain of this particular function? So domain is nothing but xy, x square plus y square less than equal to 4 and greater than equal to 0 for this particular function. What is range of this particular function? Z. So z less than equal to 2 and greater than equal to 0. So this particular function will produce always in this range, greater than equal to 0 and less than equal to 0. You can put this value. So x square plus y square is less than equal to 4 and greater than equal to 0. So if you put here 4, so it is 0. So it cannot go below that. And x square plus y square if greater than 0, so if you take anything, let's suppose 2 or 4 or 0, let's suppose, so 4 minus 0, 4 minus 0 is nothing but 4, so root 4 is 2, so maximum value will be less than equal to 2 only. So these are the domain and range. Let's take one more example for this domain and range. So when we say the function is continuous, so what is the actual meaning of continuous? So take this y equal to 1 by x. So as we know that this particular function, if it is defined, then x should not be 0. So x not equal to 0. So that means this particular function will be defined either when x equal to greater than 0 or x less than equal to 0. So let's take the graph for both. So what is the graph for this? So for x greater than 0, so graph is this. When x less than equal to 0, so the graph is this, plus infinity, minus infinity here, plus infinity at y and minus infinity. Similarly here, plus x, plus infinity, minus infinity, this is plus infinity, minus infinity. This is x axis, this is y axis, this is x axis, this is y axis, and this is the graph. And at x equal to 0, this function is not defined. So you can see here when it is 0, it is not taking any value of y. So can you tell me what is the domain of this one? So domain of this is x greater than 0. So x is taking always 0 0 till plus infinity. For this, what is domain? So here x less than 0 it is taking. Now the important thing is what is range? What is the output? Output for this one, what is this? If you see here, so y greater than 0. Y is always 0 when x equal to, when x greater than 0, y is always greater than 0, if you see here. And here, when x less than 0, y is less than 0. At minus side you can see here plus side. So I hope you would have understood what is how to calculate domain and range and what is the actual meaning of domain and range. So having understood this one, let's go to the next concept and let's understand this same concept on the trigonometrical function. So let's take this trigonometrical function of sin x and cos x. So because this is the base for all the trigonometrical function like tan x, cot x, sec x, cosec x. So let's first understand what is the domain for sin x. So domain for sin x is, you can see here, it is all real number. So it is taking all the real number from minus infinity to plus infinity, you can see here in x. So domain is all real number. Important thing here is that what is range actually. So if you see here for sin x, the range is between minus 1 to plus 1. So this particular function will never produce value above 1. It will never go this side or this side of minus 1. It will be always between this c. So you can see at 0 it is 0, pi by 2 it is 1, pi it is 0, 3 pi by 2, here you can take minus 1, 2 pi, 0. So it will be from minus 1 to plus 1 only. So the range is this. Similarly, if you go for cos x, the domain is real number, all real number from minus infinity to x infinity in x-axis, and range is also same for this cos x, minus 1 to plus 1. So for this also it will never go above 1 and below minus 1. So having understood this sin x and cos x, let's go and derive the domain and range for this particular function, which is nothing but tan x. So tell me what is actually tan x. Tan x is nothing but sin x divided by cos x. So if tan x is sin x divided by cos x, that means this cos x not equal to 0 always, right? If it is 0, then tan x is not defined. So that means cos equal to not equal to 0. So the meaning here is that wherever the cos x value is giving 0, this tan x is not defined. So at the value of pi by 2, this tan x will not be defined. At the value of 3 pi by 2, you can see, if you see this graph cos x, at pi by 2 it is giving 0, at 3 by pi 2 it is giving 0. So wherever the cos x is giving 0, this tan x is not defined. So we'll see in this graph. And what is domain of this particular function? So domain is are all real number. So what we have to do, what I said, this tan x will not be defined for all value of x where the cos x is giving 0. So at 5 by 2, 3 pi by 2, 5 by 2. So we have to subtract this one, right, from this real number. So this minus 2n plus 1 pi by 2. So when n equal to 0, so it will be pi by 2. So you can see here when n, if you put n equal to 0, so this will be 0, pi by 2. So at pi by 2 it is 0. So we are subtracting from r minus 2 pi by 2. So pi by 2 also should not be in domain. So if n equal to 1, so it is 3 pi by 2. So if n equal to 2, then it will be 5 pi by 2. So at this point we are subtracting. So you would have understood what is the meaning of this. What is range? Range as usual. This is from minus infinity to minus 1 to plus 1, you can see here. Similarly, let's see the graph of this. What is the graph of this? So if you take this graph, this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi, 5 pi by 2 and 3 pi, and go this side, this is minus pi by 2 and this is 0 this side. So this is x-axis, this is y-axis. So if you take this pi by 2 3 pi by 2, 5 pi by 2. So why I'm saying that this particular function tan x will not be defined for all the cos x value where it is giving 0. So at pi by 2 it is giving 0. So the graph for this would be like this. So you can see here at pi by 2 cos x is 0, it will never meet with pi by 2. So from minus pi by 2 to pi by 2. So domain is, you can see here, r minus 1 to 1. So this also will be my 1 to, so range will be for this tan x, let me just correct it, range will be here minus infinity to plus infinity. So let us understand the tan x here. So I have just corrected it, minus infinity to plus infinity. So let us understand the tan x. Tan x is sin x divided by cos x. So the cos x, wherever the cos x is 0, this particular function will not be defined. So you can see here, it is taking range minus infinity to plus infinity, but the domain is this one. So you would have understood what is the actual meaning of tan x and this all concept. So let's see the concept for this. Now see the cot x. What is the domain and range of this? So for this cot x, what is the formula? This is cos x and sin x. So that means this cot x function will be defined when the sin x not equal to 0. If it is 0, then cot x will not be defined. So that means wherever the sin x is taking 0, this particular function will not be defined. So you can see here at 0 it is taking 0, at pi it is taking 0, at 2 pi it is taking 0. So domain will be all real number minus n pi. So you can see here at pi, so if you put n equal to 0, so it is at 0 it is taking 0, so we are subtracting from real number. So domain is all real number, just subtract wherever the sin x is taking value 0. What is the range of this function? The range is minus infinity to plus infinity, and graph for this is nothing but this pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, and 3 pi. So take this break. So the graph for this is opposite to tan x. So this is like this. Wherever sin x is taking 0, it is not defined. So you can see sin x is taking pi at pi. Sin x value is 0. If you put 0 here, it will be undefined. So here also it is undefined. It is parallel to this pi. So it will go plus infinity, minus infinity, and here it is plus infinity. So let's understand another one. Now let's see sec x. So how to write sec x? It is 1 by cos x. So here the cos x should not be 0, otherwise this function will not be defined. So that means wherever the cos x is taking value 0, this particular function will not be defined. So what is the domain of this function? R minus 2n plus 1 pi by 2. So at this particular place, this particular function sec x will take, otherwise it will not be defined. So what we are taking all real number, we are subtracting where the cos x is taking 0. So if at pi by 2 it is taking 0, so if you put n equal to 0, so what would be this? So you can see here at pi by 2, put n equal to 0, so it will be pi by 2 where it is taking 0 cos x. If you put 1, then 3 by 2, so we are subtracting. So what is the range of this sec x? So the range is open interval minus infinity to minus 1 close interval, then union close interval 1 to infinity open interval. So this is closed interval and this one is open interval. So what is the meaning of this open interval? Here this particular value will not be included, and in closed interval that one will be included. So it's an inclusion and exclusion of the value. So what is the graph of this? So if you take this graph, so this is pi by 2, here pi, 3 pi by 2. So just take this one. So you can see here the domain is r minus 2n plus 1. So wherever the cos x is 0, it is not defined, and the value is minus infinity to minus 1 and plus 1 to plus infinity. So this will be like this, it will never meet at this point at pi by 2, because at pi by 2 cos x is 0. Similarly here in minus side also, so this is minus 1, this is 1. So this will be like here, this is the actual minimum, and here it will not go below that. Let's see the cosec x. So let's see the cosec x graph. So the cosec x is formula is 1 divided by sin x. So here cosec x to be defined if sin x not equal to 0. If it is 0, then cosec x will not be defined. That means wherever the sin x, this particular graph is taking 0, this function is not defined. So what is domain? So all real number minus n pi. At n pi place, this sin x is taking 0. So you can see here at 0 it is taking 0 pi. So n is 0, then 0. If n equal to 1, then it is pi. So we are subtracting this. What is the range of this? Similarly, minus infinity to minus 1 close interval union 1 to infinity close interval. So what is this one function? Pi, here pi by, this is pi by 2, this is pi, 3 pi by 2, 5 pi by 2. So this is minus infinity to minus 1, 1 to 1. So it will be at, this is pi. So here it will be like this, and this will be like this. This is 1, this is minus 1. So having understood this trigonometrical function and their graph, let's go and see some simple formula to do the differentiation, and then product rule, quotient rule, and chain rule. So let's discuss this. So if you can see here, so to do some basic differentiation, we should have some basic concept related to this, how to do the differentiation. So you can see here some of the formulas here. If you do the dy by dx, differentiate this constant in respect to x, you will get always 0. If you differentiate x power n, it will be in respect to x, then it will be n x n minus 1. A power x, if you differentiate, then it is a power x log a. E power x is nothing but e power x, if you differentiate is same thing. Root x 1 by 2 root x, log x 1 by x. So root x, you can apply this formula here. So root x is nothing but x power 1 by 2. So here it is in the form of this x power n. So what is this? 1 by 2 x, 1 by 2 minus 1. So 1 by 2 x, this 1 by 2 x minus 1 by 2. So 1 by 2, can we write this? 1 by 2, we have taken down 1 by 2, 1 root x. This is nothing but this. So you would have understood how I have generated this. So let's see some other examples. So if you have a function like that, di by dx fx plus minus gx, so we can do like di by dx fx plus minus dy by dx gx. So you can do like that. If you have dy by dx c dot fx, that means constant and then function, so you can take constant out, and dy by dx fx, you can differentiate like this. If you have dy by dx fx multiply by gx to function in multiplication, can we write like that, dy by dx fx and multiply dy by dx gx? No, this is wrong. Here we have to apply product rule. We cannot do like that. So we'll see what is product rule. Similarly, tell me, can we do this also? If you have a function like dy by dx and then fx divided by gx, so can we write like that, dy by dx fx and dy by dx gx? No, this is wrong. We cannot do like that. We have to apply quotient rule. So we will see that. So let's see some of the examples for this. So let's take this example, y equal to x square. So we will apply this formula. So dy by dx equal to 2x. Another example, if you take y equal to x square plus 2x plus 1, so if you differentiate it with respect to x, so it is x power n, so you just apply this formula, so it is 2x, here 2 and x. So I have already explained that when dy by dx c dot fx, this is constant and this is fx, so you can take constant out and differentiate it this, so x differentiation x power 1, so it is nothing but 1, and constant differentiation you can see here, it is 0, so it is 2x plus 2 dy by dx, and this is nothing but a slope of this particular function. So let's see one more couple of examples. So if you have a function y equal to tan x plus 3 cot x plus 4 cos x, so dy by dx tan x equal to sec square x plus 3 cot x, you can see here, minus cosec square x plus 4 cos x differentiation is nothing but sin x, so it is 4 minus sin x. So if you solve it, sec square x minus 3 cosec square x minus 4 sin x, so this is the differentiation. So now let's see what is the product rule. What is product rule? So we have seen that if you have a function like dy by dx and then fx plus multiply gx, then we cannot go dy by dx fx multiply dy by dx gx. That is the wrong way to do. We have to apply product rule. So product rule is saying first take fx out, then dy by dx gx you differentiate it, then plus take gx out, then differentiate dy by dx fx bucks. So this is the formula. So if you take this one, x square log x, so here we have a two function, 1 and 2. So what we will do, dy by dx is nothing but, first of all, x square out, differentiate this one, so log x is nothing but 1 by x, so it is 1 by x, then plus take log x out and then differentiate x square by applying x power n, so it is 2x, so x and x cancel, so it is 1x plus 2x log x, so take the x out common, 1 plus 2 log x. Now what is quotient rule? What is quotient rule? So as we have seen that if we have dy by dx and one function this and second function this, we cannot just divide like dy by dx 1 and then dy by dx 2. This is wrong. We cannot do this one. So what we have to do, So 1 is nothing but function 1, which is fx, and this is gx. So how to do this one? So first of all, we have to 2 square and then take 2 out, dy by dx differentiate 1, and then minus 1 out, dy by dx differentiate 2. This is the formula. So if this function is given, let's suppose x minus 1 and x plus 1, how to do this? So dy by dx, this is function 2, this is function 1. So 2 square, x plus 1 square, then 2 out, x plus 1 dy by dx x minus 1 minus, then this is x plus 1, then x minus 1 out, dy by dx x plus 1. So if you differentiate it, what is this? X plus 1 dy by dx x minus 1 is nothing but x is 1 minus 0, then minus x minus 1 dy by dx, this x differentiation 1 and constant is 0, x plus 1 whole square. So if you take this x plus 1 minus x minus 1 x plus 1 whole square. So if you solve this one, this will be cancelled, and this will be 2 x plus 1 whole square. So this is the answer for this one. So let's see what is chain rule. Let's see what is chain rule. So chain rule is like when y equal to sin x is given to you, you can differentiate it dy by dx equal to cos x by applying this rule. But when y equal to sin x plus 1 is given to you, then what you will do? So you can see here it is one function, inside that another function is there. So to differentiate this one, what you have to do? First you have to dy by dx, this is chain rule. So assume this as x, so sin x differentiation is cos x, so cos x plus 1, then differentiate this also. So what is differentiation? X is 1 and this is 0, so this is cos x plus 1. Take some more example here. I think you would have understood what is chain rule. If you take this one, let's suppose y equal to sin x square plus 5. So dy by dx, here one function is sin, and inside this is also one function, so treat this x. So it is cos x square plus 5. Now we have to differentiate this x also, because this is also one function. So this is 2x and constant is 0. So this is 2x cos x square plus 5. So I hope you would have understood all these concepts. And if you have any questions, please write on the comment box. I will try to answer as much as possible. Thank you for now.